Welcome back to Dr. Liu's VCE Chemistry channel. Today, we are breaking down volumetric and chromatographic analysis from the 2018 VCE Chemistry exam. As I go through this, please feel free to correct me if you find any mistakes. All feedback from teachers, parents, and students is greatly appreciated. A clear, colorless liquid extract of the rhubarb plant was analyzed for the concentration of oxalic acid by direct titration with a recently standardized and acidified potassium permanganate solution. The steps in the titration were as follows. Step 1, a 20.00 ml aliquot of the rhubarb extract was placed in a 200 ml conical flask. Step 2, the burette was filled with acidified 0.0200 mkm NO4 solution. Step 3, the acidified 0.0200 mkm NO4 solution was titrated into the rhubarb extract in the conical flask. The titration was considered to have reached the end point when the solution in the conical flask showed a permanent change in color to pink. The volume of the titer was recorded. Step 4, the titration was repeated until 3 concordant results were obtained. The average of the concordant titers was 21.7 milliliters. During the titration, a 20.0 milliliters aliquot was analyzed using 21.7 milliliters of a standardized potassium permanganate solution. Utilizing the 2 to 5 molar ratio, permanganate to oxalic acid, established by the chemical equation, the procedure involves first calculating the moles of oxalic acid reacted and then determining the molar concentration in the original sample. While the conical flask was correctly rinsed with distilled water, the pipettes and burettes were not. The correct procedure requires that both the pipettes and burettes be rinsed with the specific solution being transferred to ensure the concentration remains accurate. Ascorbic acid, a weak acid and a strong reductant, has its concentration commonly determined using 2 titration methods. Due to its weak acid nature, its concentration can be measured by acid-base titration with a strong base, where the equivalence point is above pH 7, making phenolphthalein the most suitable indicator. Alternatively, because it is a strong reductant, its concentration can be found using redox titration with iodine, utilizing a starch indicator to signal the end point. Researchers have developed a technique that allows high-performance liquid chromatography, HPLC, to simultaneously determine the concentration of sugar, organic acids, and alcohols in fermentation products and food samples. The table below shows the retention times for some common organic molecules using this technique. The retention time of HPLC is an intrinsic property used to tentatively identify organic compounds based on their unique interaction with the stationary and mobile phases. In this analysis, peak Q, with a retention time of approximately 15 minutes, exhibits chromatographic behavior similar to that of the glucose standard. Similarly, peak R, eluting at approximately 20 minutes, corresponds closely to the retention time of the glycerol standard. Therefore, it is inferred that peak Q represents glucose and peak R represents glycerol. Retention time is a direct measure of an analyte's relative affinity for the stationary phase compared to the mobile phase. Differences in retention times are governed by intermolecular forces, such as molecular size, but dispersion forces. On a non-polar stationary phase, a larger molecule will exhibit stronger London dispersion forces and therefore have a longer retention time than a smaller molecule. Polarity: a polar analyte will be more strongly attracted to a polar stationary phase or a less polar mobile phase than a non-polar analyte, resulting in a higher retention time. Miscanthus florigelus is a type of grass that is approximately 37% cellulose by mass. M. florigelus is being researched as a feedstock for bioethanol, CH3CH2OH, production. The cellulose in this grass can be used to produce CH3CH2OH, as summarized in the flow chart below. In each step of this process, there is an incomplete conversion, and waste products are formed. A researcher utilized HPLC analysis to determine that 144 L of ethanol was produced from 1,000 kg of M. florigelus, which has a 37% cellulose content. The mass of the available cellulose is calculated to be 370 kg. By multiplying the density and the volume of ethanol produced, the mass of ethanol can be determined. Finally, the percentage yield by mass of ethanol produced from the cellulose in M. florigelus is calculated. The energy yielded by 144 L of ethanol is calculated by first converting its volume to mass, and then multiplying that mass by the heat of combustion value. Ethanol molecules possess a polar hydroxyl OH group, which facilitates hydrogen bonding between molecules. Since hydrogen bonds are significantly stronger than the weaker dispersion forces present between nonpolar petrol molecules, the inclusion of ethanol in the fuel mixture introduces the stronger intermolecular network. This enhanced molecular attraction increases the internal resistance to flow, thereby raising the fuel's viscosity. This is a key 14-mark section, 11.7% of the paper, covering 2 critical lab techniques. To succeed, focus on these areas: master titration. You must be able to solve a redox titration problem, oxalic acid concentration, know the correct rinsing rules for all glassware, and understand the difference between acid-base and redox methods, ascorbic acid. Analyze HPLC results. For chromatographic analysis, you need to use retention time to identify compounds, and more importantly, explain why those times differ by discussing intermolecular forces, hydrogen bonding versus dispersion forces. Complete the applied math, be prepared for a chained calculation, calculate the mass of ethanol produced, then its percentage yield, and finally the energy output from its combustion. Explain viscosity. Use your knowledge of intermolecular forces, like the strong hydrogen bonds in ethanol, to explain the change in a fuel blend's viscosity. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.